An energy level diagram is a one-dimensional graph. So I'm going to put one axis. This is going to be a vertical axis going up and down here like that, where you're plotting energy. And these would be energy of those orbitals. This is the energy of the orbitals in the quantum mechanical atom. So let's see how far down I go here. So if I draw a line down here, what I'm doing is I'm marking like that particular energy right there as the energy of that first quantum mechanical orbital, which we called the 1s. Okay. And the next orbital, the next fuzzy cloud that I drew on that other picture was, say it's right here, and that would be the 2s. Okay. Now, the next orbitals, which are the p orbitals, for hydrogen, they're exactly the same energy level as the 2s, but in order to fit them here, I want to show those as well. I'm going to move those lines over here, and each line got to correspond to one of those fuzzy pictures. But for the s's, there's 3 of them, like that. So just to remind you of what these are representing, I'm going to draw the little fuzzy picture below the line. So like there's that first orbital. There's the next one. So the only difference between these really is that its size. They're the same shape but different size. So the 1s and the 2s. And then the p orbitals, these are the 2 p orbitals. They would be those dumbbell-shaped ones. Going that way, going up and down, and then going. I didn't draw this one, but there's one going in and out of the board like that. Then you go to the next one, keep continuing like that. You have your 3s. The s level also has some p orbitals. I'm not going to draw those, but they'd just be bigger than these. And then, in addition, you have that other whole set of orbitals that I labeled over here as Ds. So this is kind of how the picture of the atom is built up. And you'd have a 4s, you'd have 4 p's, you'd have 4d electrons, but then also with once you get to level 4, you have a different shape coming in, which are the f's. So in level 4, you start with the f orbitals.
Why would the 2p have 3 lines?
And the 3p both have 3 lines because there's these different, there's the different directions in space. So there's 3 different 2p orbitals. They're all the same shape and size, but they point in different directions. This one points horizontally, this one points up and down, this one comes out of the board. They're all perpendicular to each other. So the difference between them is, it's called their orientation in space, their spatial orientation. That's what gives you the difference. As a matter of fact, there's a label that we can put on the orientations to distinguish them from each other, and it's called the magnetic quantum number. So just like there's a label for the level 1, 2, and 3, and a label for the shape S and B, there's also a label that distinguishes the directions in space, the spatial orientations from each other. Matter of fact, I'm going to add that to this picture by writing it in here. There's an M with a subscript L, the magnetic quantum number, and it has values. In general, it has values from -L to +L, where L is a number that you can give for these different levels. So I'm throwing a lot at you right here that it's in the chapter, but you know that's why I said there's a lot in this chapter. So let me write this over on the side. There's a there's quantum numbers. Okay. There's the principal quantum number n, and that labels the size of the orbital. Then there's also a quantum number L, which labels the shape of the quantum number. And you have, remember, you have the letters that label the shape as well. So there's two ways of labeling a shape. You can use a letter or a number. So for L equals 0, that's the same as an S. For L equals 1, that's the same as a P. And for L equals 2, that's the same as a D. And then 3 is an F orbital. So we already looked at the letter designations. Now I'm throwing in the fact that there's also a number designation for those letters. Then the M is the third quantum number. There's 3 quantum numbers that label every orbital. M sub L labels the spatial orientation. Not sure if you can read that word spatial. That says spatial orientation. Means either this way, or this way, the perpendicular directions that they are to each other. So like on this particular picture, this direction is an M sub L of a -1. This would be 0, and this would be +1. M sub L has a range from -L to +L. So it equals, it starts with -L and it goes all the way up to +L. That's the range of the M sub L quantum number. L has values up to n-1. So that's why in the second level, you can have an L equals 0 and an L equals 1, which would be p orbitals. These numbers are important. They all have their ranges. And then also understanding that each of these lines can hold at most 2 electrons. And so that's how you get your electron placed on the quantum mechanical atom, is doing these first by energy level, energy order, and then in addition to that, you have to remember that there can only be 2 electrons in each of these levels. And once you start putting electrons in those levels, that's what's known as an electron configuration. Now also I wanted to point out that this energy level diagram, this particular one is only for hydrogen. Because hydrogen only has 1 electron in it. Once you get more than 1 electron in an atom, these sublevels that are in here, at the different shapes, they have slightly higher energies than the ones that come before them. So there's a splitting in here of the actual energy levels compared to this picture. Right here, these and these other ones are all the same energy. But in topic, I'm going to cover how you would fill in this picture for what's called a multi-electron atom, which basically just means anything other than hydrogen. So I'll give you a different picture, still sort of like this, but with these energies split. And that'll be another topic